And we are live. Hello, everyone. Hello and Happy New Year. And welcome to our first ever session for 2021. Today, your host for the virtual jug would be myself, Ivan Ivanov. And I have the great pleasure to welcome again to the virtual jug my friend from Romania, Victor Rentia. But before I give you the opportunity to consume his great energy, let me show you a few slides because we can't do without slides. And I'm going to share my screen, and I hope you see my screen now. So we are the virtual Java user group, that is going online since its inception, even though that today every Java user group goes online or every conference goes online. We are online since the beginning, and we have more than 15,000 users that are our members. We would like to thank to our generous sponsors from Snike for sponsoring this event. That actually our Zoom streaming service. Snike, for those of you that don't know what it is, Snike is a company that creates developer tooling that enables developers to scan their projects for known vulnerabilities in their open source dependencies. Thank you very much, Brian, for putting this for me here. And what else? So I hope that you are all on the virtual jug Slack. If you're not there, go there and log in. And there's the live session channel there where you can post your questions. Any questions that you have for Victor, I'll be happy to relay to him. I will ask the questions at the end of his session. It's Victor's request. So, but whenever you have a question, just don't wait for the end. Post it there, and I will ask all your questions at the end. Of course, you can provide feedback at the virtual jug channel, at the virtual jug Twitter handle, or to my Twitter handle as well. I will monitor that too. And without further ado, let's see what the session will do today. So today we are going to talk about tests, about mocks, and the session title is "Don't be mocked by your mocks." And our speaker, as I said again, is Victor Rentia, who is going to be speaking for the second time, if I didn't get it wrong, in our virtual jug. So welcome back, Victor, and I'll stop sharing and we'll give the stage to you.
Hi, and thanks a lot for making this happen. I'm super excited to meet you in such a great number, and really excited that, of course, all the situation that we're living now, it's terrible, but it does have some positive effects, right? So we can meet now from everywhere and discuss and share our passion for Java and not only. So let's get started because I have a lot of stuff to cover. Don't be mocked by your mocks. I need to explain first. The word mock in the dictionary, the first meaning, to treat with contempt or ridicule, to disappoint, to defy. These are the three meanings, the first three meanings. Only then it means to imitate. Okay, so the purpose of today's discussion is how not to be mocked by your mocks, so that is not to get into trouble by using mocks. I'm Victor, I'm one of the 2 Java champions in Romania, and my heart is with simple design, refactoring, and unit testing. And to have a place where to share this passion, I started my own little community in Romania, which is not that little anymore. We are over 2,000 developers, one of the largest in Romania today. If you check my website, you can find a blog. I just started it. You can have a collection of my best talks and other goodies. Now, 1 year ago, almost, I left IBM. I was a lead architect there. I left in order to do more trainings and more discussions and to help more teams. That's what I'm currently doing full time. I started doing it 8 years ago, thousands of developers, dozens of companies, hundreds of teams. This is insane if you think of it. 100 of online webinar days since the pandemic. My comfort zone, of course, is the Java world, right? Spring, Hibernate, and functional programming, advanced patterns. But what I'm most requested for is the language agnostic part, and which actually I love most, design patterns, refactoring, and unit testing. And we'll be talking about one part of this training today. One full of one very dense part that related to mocks. Of course, reactive programming and Java performance. This is way more and more demanded these days. In case you are interested you can join a live webinar on Teachable on Zoom directly with me, you can check out my website. There you can find also the full agenda of every training that I do. And trust me, it's very, very good. I'm also on the social media, posting stuff, and that's about it. Now, today we'll be talking about one part of the unit testing. So let's dive right in. Well, the first question that I will ask is, why do you ever want to decouple a dependency from your test? Why do you want to not to include a certain production class in your tests? Well, certainly you want to do that because you want to build isolated tests, repeatable tests that don't depend on a database being turned on or on the data that is currently in those tables. And also because you want to build fast tests. But that's quite reasonable reason, because nothing beats a process which runs just in memory, right? So you could avoid an external API call or a database select, for example, by using what? A dependency. I mean, a fake, an object that you swap in the place of the real production object. However, when I ask my trainees, what other reasons they have for using mocks, many of them will tell me that they would like to use, they are using mocks to be able to test less code in their tests. What they will do really, what we all do, we will mock the layer below and we will test from above, for example. You can decouple parts of your application and test them in isolation. I mean, we will understand today that doing that might really kind of be a sort of a cheating sometimes. That's mainly the problem of this talk. We'll get to that. But first, I want to get you to the theater. Oh my God, how long it's been since you've been to watch a play, right? And on that stage, imagine this moment in which the wife asks the husband, "Dear, do you love me?" Of course, he is bound to answer, "Yes, I do." So this is one kind of an actor which answers in a certain way to a specific question. Very good. Now imagine another moment in which the same wife perhaps will slap her lover, splash. Now in the backstage, imagine the director. Imagine taking the face of this actor and checking the size of the palm that is imprinted on his face to verify that it's the correct method that he had to be invoked. So this, however, is an object which doesn't really tell anything. It just just suffers a method invocation. Nice. We've just seen two ways that our mocks really can behave. The first one is a stub. Really. That's the official term from the classification. The stub allows us to program an object to return something whenever a certain method is being invoked. Dear, do you love me? Of course I do. Then a mock is that actor which takes a slap, and then in the backstage, you verify that the save method really happens on that repository. Good. These are all kinds of tests. There are two types of test doubles. Now, there are other kinds, but unfortunately, you never heard of a stub before, right? Many of you have never heard of a stub. Why is that? Because the frameworks that we're currently using in Java, they all contain the word mock inside their name. And that's why you only talk about mock. Okay, but it's about how you handle a method. We will go there. But before that, there are other kinds of test doubles in the room, one of which is dummy. Now, a dummy, you don't really teach it to do anything. It's just an object sitting there in order to avoid the null pointer exception. That's it. So it's not really doing anything. You can think of it like a mock, which is not programmed to do anything. Okay, not very useful, really. Another type already, however, is quite interesting. It's called a fake. Now, this means that you would implement, again, the same API, the same interface, but with a different implementation just for the sake of the tests. You will build a test implementation of a repository. Imagine that. So instead of stubbing this method to return a certain user, okay, You will rely on such a fake implementation that stores stuff in an internal hash map in memory, right? An alternative implementation of the same repository interface. And that repository, that fake repository, will allow you, instead of stubbing a method, to just save something with the ID one, such that the production code, when it does find by ID, it will get from the map by the ID one the same instance. So you can avoid stubbing by saving. And guess what? Instead of verifying that something was saved in the repository, you can actually let the production code save to the order repository and then take all the orders out and verify that among those orders, there is also the new order that the product call should have inserted. So a fake is a sort of an alternative implementation just for use in the test. Not very widespread, I'm afraid. When should you think of it? In case you are copy-pasting a lot of times the same stubbing, right? If you copy-paste the same stuff in 10 places, you might think of using, but more than that, in case you ever go and mock a method by dynamic mocking, by programming a method to return the result of a lambda, of a callback. And whenever you do that, please try to think of building a fake, another alternative implementation. Nice. Now, but fakes and dummies are just, interesting, but they wouldn't be really, one second, I have an issue with my nightlight. They won't be really that widespread. However, mocks and stubs, now that you work with them every day. Now, stub and mocks really means how you treat a method. If you program a method to return something, you get a stub. If you then expect that to be called from production code, that's a mock. So you stub and mock methods. Really. Now, Martin, how to put this? Big surprise, mocks aren't stubs. Now, we didn't need Martin Fowler to tell us that, right? But it's very interesting, this discussion. The article says that you should stub queries and expect actions. What? No, this is a query method, meaning that it brings data. Given an ID, we'll get the user into the production code. Perfect, a query method. Now, this is, in general terms, this is an action. Performs side effects, changes stuff, it inserts stuff. Good. Now, the story goes like this. In case you ever stub a method to return a user, for example, then if you do that, you should not be verifying that find actually happened. You should not be doing that. Instead, you should verify what the tested code really did based on the state of this user. Maybe it returned a certain value, maybe it threw an exception. I don't know. Verify the effect on the production code of that stubbing. But this goes deeper than that. There are times in which you would both need to program to stub a method and verify. Because sometimes that method both returns information and has critical side effects that you want to check and to verify. But if you do that, you are really violating one principle, which is called command query separation principle. A method should not both return value and do side effects. It's a very deep principle. Go Google it and go read about it. Command query separation, 94, Bertrand Meyer. The very interesting guideline. So in case you are facing a case in which you have to both stub and mock the same method, then you are kind of violating one principle. You see, this is the first time we will see a design hint given to us by tests. We will see many of these, right, today. Good, let's move on. Before we even start, I need to discussing more in-depth stuff. I want to make something clear. I want to define the concept of a pure function. Now, you see, a pure function is not allowed to do any side effects. You should not be doing inserts, sending messages on queues, changing files or fields, nothing. A pure function does not change anything when it's called. And more than that, it has to only return values. But not only did it return values, it returns the same values if it's given the same argument. So you see, you are not really allowed to rely on the current time, or even a get over network or a select from database will bring different data if someone inserted a row and committed in between. So you see, the geek word for this is that the function is referential transparent. Yeah, referential transparent. It's a geek word, but in simple terms, the most simple example you can think of a pure function are mathematical functions that just compute stuff. Fortunately, nothing changes if you call this function, and will get you back the same results every time for the same inputs. And this is it. We are now ready to start the marathon. And we start the marathon by putting the pieces into place with a little philosophical slide. In broad terms, in general terms, what can a feature do? What can you verify that a feature did? For simplicity, let's think about just a single method for this exercise. Now, calling a method, you could then verify whether this method returned the correct result. So this is verifying the outputs given a certain input. Perfect test. Unfortunately, many functions take their data not just from inputs, but from other dependencies. Like they will go and load stuff from database or query over network, something, right? This means that you need to consider both the inputs and other parties into this game to then be able to assert what the output was. Nice. Now you can either let that method do the real stuff and maybe even go to let it go to the select in the database and run the select, or if you don't want to involve the database into this game, you can just stub it, and when then return on the repository to program its return some user like we just did. Good. Now the bad news is that a feature or a method doesn't just return values. It can also change stuff. These changes, if they reflect on objects in your memory, you can easily just assert the changes after the function ran. So, right? You can just assert that user was activated, for example. However, if those side effects go far away on external systems, you are facing a decision. You can either let that production code do the insert and then come with a select from the test to verify that the insert really happened, or you can just verify that the save was called on the repository and rely on the, I don't know, Spring Data Framework or Mongo repository to really insert the stuff later on and trust the frameworks. This is called interaction testing. These are the decisions that you really have to take very often. Now, from all these kinds of tests and things that you can verify, by far, the best test that you can write is that doesn't really rely on anything else but inputs. I mean, how to put this? These are the most simple tests to write. Input, output. No hidden inputs, no mystery, no dependencies, no weird stuff happening under the hood. And now comes the fun part. For simplifying the tests, I would ask you to purify this feature, this method. What does this mean? I will take more as a parameter, and I will try to return back the things that I want to change. What? What do you mean? I know this calls for an example, so try to test this function. Now imagine this is very heavy logic, right? Like very complex ifs and fors and while and right? But this function also runs a query in the database and then saves stuff in the database. Nice. Now, to be able to test this, you will probably need to stub away the repository, to cut away the database, not to depend on it. Okay, and then you should verify that the save really happened. Now, if you look closer, how would you verify that the delivery counter was correctly set? We need to get your hands in the test on the order instance. But the bad news is, look carefully. The bad news is that the order instance never exits this function. It's not visible from outside. So to get your hands on the order instance, the only possible option you have is really to capture the argument that was given by the production code. It's called argument capture in Mockito. So, imagine doing this 8 times, because that heavy logic requires 8 passes to the different workflows inside to verify all the behavior. Repeating this garbage 8 times will lead to painful tests. And I will say that the most simple tests we can ever write are those that don't use mocks at all. Then come those that you stub and verify. And the worst kinds are those that require you to capture arguments. Very hard to debug, very hard to understand, and fragile and brittle and frustrating and so on. So your goal here is to actually bring this logic out in the tests and test that part. That's the risk. That's the real logic. So what would you do? You would like to bring that under test, only that part. So the first step, extract it. Let's try that. First, what will be the parameters for this method? Well, look closer. I need to have the user. So the user from here needs to go in. I will expect also the card to be used somewhere in between. And what will get out of the function? Well, the order, of course, because I need to persist the order. There you go. Input, output, and 2 arguments and 1 order return. There's your function. Returning the order and taking these 2 parameters. Very good. Which is a pure function. Brilliant. Now, because it's a pure function, however, you do have some trade-offs to take. There are some problems. You might end up passing more parameters. And you should design something at some point. Or you might get more complex return data structures than just a single object. It's interesting, and that's a design decision. But the benefit is that you can safely test this a lot with a lot of simple, super simple tests. And you run your tests on that function, very easy test without any mocks in between. Nice. Now, what this means really is that you've managed to bring this class in what we call a circle of purity. This circle of purity it may be new to you, but you should be aware of the onion architecture or the hexagon or porta. It's the same thing. It's such a fundamental idea that it gets reinvented every 5 years. Everyone tries to rebrand it somehow. It's the same basic idea. The universal architecture very briefly means that your domain should be agnostic of the infrastructure that surrounds it, of the external world, should be focused on doing its job and not be concerned of interacting with the external world. Now, inside your holy domain, your sacred domain, I want you to try to isolate a functional core composed of pure functions. Functions that take arguments and return values, nothing more. This will force you to push all the side effects and the dependencies in an imperative shell. This is, you don't hear about this principle very early in your career, but Google it. Imperative shell functional core. It's a very subtle design idea that will isolate bits of bits of pure functions in the middle of your, especially exactly where it's most complex. That's the point. The most complex part of your logic, you should model them as pure functions. Not only because they are easier to test, they don't involve mocking, but they are also easier to understand. There are no hidden dependencies, no weird side effects, no temporal coupling. Easy stuff. Plain sight, input, output. Good. Oh, that's pure. Yeah. So we did it. It is pure. Very good. But then, what happens with the other function, the one that we extracted this from? It's called create order, right? So the question is, how do we test that? And we already can place that function in an imperative shell, if you like. That's doing dependency and side effects. Good. Now, how would you test that one? Well, the question that I have for you, should these tests also get to run this other create order function? Well, remember, we've just tested that quite a lot. Now, there's a very interesting discussion here. And in simple terms, very simple terms, you could allow the call to happen. I mean, you get the point, right? When you test this function, the question is, should those tests also get to call or create order? Well, if you leave the execution to go there, you might run into the following problem. Look here. What happens if the address of the user is null? What happens if the address of the user is null? Then, let me tell you. Right? That's it. You're screwed. You got a beautiful null pointer exception because nothing is there. So basically, create order will fail if the user doesn't have an address. So testing the place order then will force you to stop this find by ID with such a user that has this address. Otherwise, you get a null pointer exception. So you see, from this perspective, the tests above here need to grow, need to have more info, more data, more stuff in order to avoid crashing with exception on this line. This is quite unexpected. I didn't want that. So let's see what happens. Now, if this problem only happens once, so imagine just really testing just this function. How many passes through you require to test this function? Well, one. With one single pass through the function, you test it all. Now, this is okay. So if there are a few number of tests around here, I'm perfectly happy that you just leave the call to happen. No issues about that. However, what if this method starts to grow and more complexity is being added? But if you have many branches in here, you will need to have multiple tests. And then the question is, what if you have many tests calling this function? Well, I certainly don't like to be able to be forced to stop the user with a valid address and all sorts of other stuff many times. You see, it's a trade-off here. If you get to test that a lot, then you might not want, I mean, if you leave the call to happen, first of all, your tests here will start to grow. And secondly, they will start overlapping. Imagine changing a line here for some reason, maybe doing country.uppercase. Bang! These 8 tests plus these other 8 tests will crash. 16 tests. Yeehaw, right? This is not nice. This is frustrating. I mean, fixing failing tests that you weren't aware of, this is one of the most frustrating things in our developer life. So if there are many tests here, you might think of stopping the call to go here. How would you do that? Well, you might discover that there is this concept of a partial mock. Now, you may not have heard of a partial mock before. If you didn't, I am happy to be the first to tell you about that, and then to tell you not to ever use it. Now, what is a partial mock? Now, a partial mock, this is a partial mock. It's a single object. It's the same object. It has both tested and both mocks. The thing is here that you want to stop the tested method from calling the mocked method. That's the trick here. And you can do that really with a partial mock. You can partially mock a class, but it's insane. This is, however, bad. This is I will call it a missed design here. I mean, the tests just raised the problem to you, and you didn't listen to the tests. You didn't take the right path. What should you do in case logic piles both here and here? What should you do? Well, if there is complex logic in both places, what I will ask you to do is to respect that logic and separate it completely in a different class. Take it out and then use a regular dependency with a regular mock, maybe to decouple that. So you see, you can stop the call to get there, but not by a partial mock, but by creating a new class. And honestly, this time you apply another very subtle principle of design, which is called separation by layers of abstraction. If both that code and that code are complex, they deserve different classes. Very deep stuff, folks, very deep stuff. I don't expect all of you know all of these principles. Go ahead and read about them. They are quite interesting. But this is the moment in which some of you are thinking, wait, but I love mocks. I'm deeply in love with mocks, right? Like. I have been blind. What's wrong with mocks? To state it upfront, everything, it will get you to fragile tests, inconsistent tests, and maybe even incorrect tests. And we'll focus on each of them in turn. So this is where the section about the problems of mocks starts. So what is bad about mocks? Let's see. Let's look a bit about to our life as developers. So this is the production code. The production code of every company looks the same. This is the production code. In the production code, you have to do a difficult change. This change. Now, of course, you can put the change right on top of it and just screw it. I don't care. But that's not the point. You are hired as a developer to find the most simple solution that will accommodate this new change. The simplest possible solution. That's why Kent Beck says that you first need to make this change become easy to apply. What? You make it become easy to do by preparatory refactoring, drilling a hole in the existing code base. But drilling a hole in the existing code base is very difficult because it means you need to change existing code that runs right now, that you don't have very reliable tests, that you don't really know what happens there. But that's the tricky part. But if you are really able to drill that hole here, then it will be very easy for you to plug in the change in the most elegant and simple way as possible. So here is the code. If you have to do a difficult change, you first make that change easy, and then you do the easy change. Ken Beck, my favorite thought leader in IT, really. And this is basically where the need for refactoring really occurred. So again, as a refresh, we write tests to refactor safely. That's the point. Because when you change existing code that runs to production, I'm sure you want to make sure you don't break production. That's where the tests really pay off. That's the fundamental reason why we started writing tests in the first place. That's why PLSQL don't have tests, because they don't refactor. Anyway, so let me give you an example here. A, B, C, D. You just developed 3 little classes, A, B, C. A, B, C, as part of the same development effort, of the same user story. They both were created in the past 2 weeks, let's say. And then the question comes, so you want to test what A does. Where would you verify the behavior of A? I mean, relative to what? You could verify A by mocking B and verifying what A did at the interaction with B, stabbing and mocking B. Very well. You can actually go ahead and try to test A plus B together. What the heck is that? What do you mean by that? I mean that you should instantiate both classes, concrete real production classes, and then mock the C. Interesting. Wait a second. I can do that. I know this is not very widespread, but it's exactly the point of this training, of this webinar. This is what I want you to do. Try to test more. I will explain. But in simple terms, A plus B decoupled from C by mocking C here. Good. Or you can go the whole path and let the insert happen in the database, such that afterwards, from the test, you go ahead and do a select to verify the data really got to the database. And now, in my trainings, I will typically ask developers, which one do you want to do? Which do you prefer doing? And surprisingly, the mid-juniors will tell me that they will test A by mocking B. Whereas the battle-hardened mid-seniors, 10 years of experience, will always tell me that they will, of course, try to test A, B, C together if they can. And there's a trick. Why? Why is this difference in opinion? To get the point, let me ask you the question in a different way. Which is the simplest to write, the most easy test to write? Well, if you only have to figure out in test what A does, of course, those tests will be the shortest and easiest to write. So that's why mid-juniors will tell me that they will test by mocking B. Okay. But let me twist a bit. I mean, in comparison, imagine testing A plus B plus C. Imagine the number of paths that you need to cover. Way more difficult to write tests. But now let me ask you the tough question. Which test will allow you to sleep better at night? Which one are more stable? Imagine there are no incoming change requests, like it was the case in the previous pile of garbage here. You weren't tasked to change the production code, but you had to solve the problem in the most simple possible way. So you never were requested to change any functionality from this whole, right? So that's the case that you face very often. The requirements didn't change, but you do want to change something inside somewhere. So as long as the requirements don't change, going A, B, C, the whole path is way more stable and reliable. Why? Well, just imagine you would like to refactor B, break it in 2 classes. One of the most dramatic refactorings you can do, break B in 2. If you do that, just imagine what will happen with the test that you wrote on A, isolated from B. Well, of course, you need to split those and to refactor those tests to target either B or B1, B1 or B2. And then even worse, what happens with the test that you put on B? Whoa, that's the pain. Another most frustrating activity in our life is to refactor tests. Refactoring tests, merging conflicts, fixing unknown tests, and written code reviews are one of the more interruptions. But we got rid of interruptions nowadays, right? We are at home. But this is still there. When you want to refactor B and break it into, holy shit, you have to change the tests and split the test class into. It's insane. It's a lot of work. Wherever, but again, remember, there are no changes. So what used to work should still work. Nice. Having a test going the whole path will allow you not to touch the tests. The test will not change if you do just a little refactoring along the way. Nice. And more than that, the tests are closer to the spec. What? What do you mean by that? I mean that if you are testing B in isolation, you might very well get things wrong because you are inventing your own specification, in quotes. So they are both, whereas if you would test from A, you might actually use techniques like behavior-driven development, ATDD, maybe even fitness to write user business analyst readable automated tests, end-to-end tests. Oh my God, what are you talking about? So in simple terms, if you mock everything around you, yeah, those will be the easiest to write. But if you mock less, you will get more reliable and stable, plus more closer to the spec, more precise tests. Interesting. But most of you use spectacle. Maybe you didn't in this kind of perspective, but if you have at least 5 years of experience, if you ever had to refactor one of your own tests, then you know what I mean here. In a way, mocks will freeze your API. Once you mock something, then God have mercy on your soul. If you ever decide to break that thing, you're screwed. Officially, irreversibly screwed. Let's see. But some of you might be complaining at this moment. It might be so I can't see you like I would in a conference, but I know what you're thinking. Are these still unit testing? Is it still a unit test to go from A, B, C, and then to database? What the heck? Is it really? Inserting in a database, can you call it a unit test? What the heck, right? They will, you might be angry. I get it. I get it. You've been misinformed. My friends, what is unit testing? What's a unit? This is one of the slides that I want you to remember. It is one of the things that I'm very angry with the current state of facts in our profession. Now, I'm angry. Why do you care I'm angry? I'm angry because you will suffer because of that. Let me explain. So what is a unit? What should be the scope of a test, of a unit test? Should it be a method? Well, I don't think there is any one of you thinking that I should have just a single method. No, that's not. Should it be a full end-to-end user story? Entire flow in one unit test? Nah, too much. Should it be a class? Now there's the problem. More than 80% of developers, I've done little studies on my training. More than 80% of developers believe that a unit should be a class. You should test a unit. A unit test should focus on testing a single class. My friends, this is wrong. Let me insist. Wrong. It is not a class. Quoting the inventor of unit testing, and GUnit, and TDD, and extreme programming, my favorite came back. A unit is a unit of behavior. I know it's vague. That's the definition is the smallest part of a feature that you can test in isolation, separately, reliably. What do you mean by that? I mean that it's perfectly fine to unit test with databases and file system. And if you don't believe me, listen to Jan Cooper in this wonderful talk. This is the exact moment, together with the time in which he says that. If the time, if you look at it, go ahead and see why. I will draw the conclusion for you now. As long as you keep your tests isolated, it's perfectly fine to call it a unit test. And by the way, you are aware that you can run your database in memory, right? With H2 or HSQL, or even recently, there was a virtual Juke talk on this topic also, test containers. You can deploy your Oracle in a Docker and start it from Jenkins. I would like to see more of my clients doing that. But the point is, or even start a web service in a Docker. Dockerize the dependencies. Now that's the shit. That's really cool. That's really cool. So the thing is, as long as you keep that Docker image private to you, then your test is perfectly isolated. You can't blame anyone, right? You will put together a database, create the schema, run your tests, tear down the database. Perfectly isolated tests. And that's a unit test. I know it takes 10 minutes. I know. And there are ways to optimize that, but that's another story. But by the definition, they are isolated. But leaving aside blue whales, let's focus on things that you can do tomorrow. Well, all of these are classes that you've just created over the past 2 weeks, on the course of 1 or 2 sprints. These are fresh classes. Now, my friends, when you create the class, unless you are also some sort of a design guru, we never get it right the first time. We always, for the more complex use cases, for the most complex flows, we always twist a bit, move one method from another class to another, maybe squash these 2 classes together and then break them in 3 classes. Who knows? Things will change. No one gets the design right the first time. So if you then develop these classes, which are yet unstable still, their API didn't settle yet. You are still unsure about the design. If you then put mocks in between, good luck refactoring. If you put mocks in between these, if you would ever want to merge these 2, good joke. You have to adjust tests like insane. So the point is, don't mock between newly created classes. Allow them to evolve together. Allow yourself the freedom to merge and squash and redesign them without breaking dozens of tests. Okay. However, the question is, what with this roller? What's that? It's a stable interface. That thing, it's the same object your grandma used, your grandma used. That never changed its API. It's a standard API. It's a library or a framework, or some of my clients have this platform code that they rely on. That kind of code didn't change for the past 2, 3, 5, 15 years. It won't change tomorrow. It's perfectly safe to mock. Or if you have an interface with multiple implementations, then by definition, those implementations will freeze the API. Right? It will stabilize the API. So it's safe to test that, to mock that. Or maybe a legacy API, something that never changed for the past 7 years. What are the chances that it will change tomorrow? A little disclaimer here, since by the way, in meetups, I find the best audience. I would like to see your interaction, but everywhere I go in meetups, that's the best audience. In conferences, sometimes there are people that have to attend because their company, In meetups, or after hours, only the most passionate developers join. So because I expect that you are passionate and quite good professionals, I will tell you that I will need to do a little disclaimer. There is a little TDD style out there named London School TDD, which tells exactly to mock in between classes which are not yet implemented. Fake it till you make it. Now, if you are a very strong developer and you are perfectly comfortable refactoring tests, merging tests, working with mocks like a piece of cake, then go ahead, use it. But if you are just starting the career like half of us are doing, I would advise you try that mockist TDD style. It's too heavy to start with. If you kind of have a clear picture about the end design, do it. Sandro Mancuso is one good speaker on this. He has some nice screencasts on this. I think they are called, not Bank, but Google Sandro Mancuso live coding kata. But the conclusion is the same. When you put a mock on an API on some methods, then changing those methods become times more hard to do. Good. Now, there is yet one more problem related to testing stuff in isolation. Let me sketch it for you. In case you test A isolated, then B versus B, each one individually, then you will run into the following problem. When you test A, you will have to somehow mock or stub the behavior of B. And let's assume that you've stubbed F to return 1. What would you need to do then? Of course, on the tests you throw at B, you should have a test asserting that F of 7 returns 1, matching the contract. Ooh. And I think about now you see it. All of you see it. What happens if this changes? Trust me, you will not change this. You will just forget. And your code will get to production, the test will be green, and we will be wondering, why is it broken? Because you forgot to keep in sync those places. So every time you put a mock in between two logic classes full of brains, please be sure to keep these very tightly in sync. It's very hard to do. Actually, there is no easy solution to that. It's one major classical limitation of what we call contract-based testing, like that. When you separate the things and test them in isolation, there is no easy way out. Now, the best part. You could actually end up, another issue now. You could end up, if you test B in isolation, you might actually end up testing B in ways which are impossible from production code. Just look at it. You are passing to F x times 2. My friends, this in Java, it is impossible for you to pass a null. But if you think of F in isolation, you might very well think of, oh, but what if I get a null? You see what you're doing? You are testing stuff that you shouldn't be actually, are impossible, really. You know where, the funny thing, I want to tell you a funny story. Where did I learn about this first? I once went to Bulgaria, to a company. I'm sorry I want to give names here. But it was a very high-tech company in Bulgaria. And I was doing a little training there. And during the lunch break, I went to the toilet. On the toilet, right in front of me, of course, there was a piece of paper. What can I do? I read the piece of paper. And I was shocked to find on the same piece of paper the word toilet and Google. And of course, it caught my attention. What the heck happens? And they were talking on the door of my toilet that you should prefer testing public APIs over implementation classes. What? Of course I read it. And down there it said that if you test implementation classes, they often don't need to be tested in as much depth as the public API, since some inputs might never be passed into their methods. Exactly what I showed you. This case. Guess what? After lunch, of course, I was actually discussing unit testing. My friends, let's discuss what I saw in your toilet. Let's discuss about that. Very interesting perspective, right? Good. Oh, and please don't tell me about, but what if tomorrow, no. I'm an extreme programmer. If tomorrow comes, I am confident that I will have the skills and patience to figure out what to do when this happens. So don't think about tomorrow that in this kind of problems. So in other words, I want you to test implementation requirements, not implementation details. Now, there is a very controversial paper by James Copeland that I would advise you to read if you've been testing for at least several years. Otherwise, you will get depressed to find out that most unit testing is waste. Do read it. It's quite long, but it kind of covers this in great detail. So again, we've covered that extensive mocking leads to fragile tests. Whenever the design changes, you need to refactor the tests. Inconsistencies, because what you mock or stub in one place, you need to be careful to stub in the other part, or to assert and then stub. And also incorrect tests that test impossible use cases or simply incorrect requirement, incorrect in dreams. Nice. So my point here is that you should test more classes together, not mock everything around you. Wait a second, but let's put this to the extreme. I would like you to build deeper tests, as deep as you can, to still have them maintainable and reliable. What? But reliability, we can get with in-memory database and Docker. Yeah, it's technically possible. But how about maintainability? But imagine testing a huge use case, right? Going through hundreds and hundreds of lines of code in total. Testing it all together is insanely complex. Why? Because there are so many branches you need to also to cover and to go through. There are so many tests you need to write and so large data sets. You know, in order to take this turn, you need to have this user having I don't know what. In order to take this path, you have to take a lot of data sets and a lot of tests. Trying to do that with bare hands is doomed to fail, my friends. You cannot possibly test hundreds of lines of code in total with just bare hands. So you need to build yourself a little testing framework, a little testing DSL. So such that you can eventually, maybe even run a post on your API and then look in the database to see the data is there. Oh, and they can do even more decoupled tests. But first of all, you do see the benefit, right? If you're able to do that, you can break, cut, and destroy anything along this path as long as you keep the functionality end to end. Nice. But you can get even more end to end than that by getting the data out of the database via another API call. Makes sense, right? You post and you create, and then perhaps you search and you should find what you created. That's a classic end-to-end black box chain of tests. Nice. And that's a black box test. Now, there is nothing more reliable, more trustworthy than those automated tests. So yeah, do that. Like Uncle Bob did 2 years ago. What? Yeah, click here. I will share the presentation afterwards. I will paste it. And let me show you what Uncle Bob did. He did with Andrew Mancuso a comparative example of TDD styles, and he used this Chicago school, the classicist. And there you go. He actually ended up building his own DSL classes of his own, using which he was able to give and post. Can you suspect what happens under the hood? Let me see if GitHub, can you work with me? No. Given posts runs a post for each of these on his API. Then he creates Alice who follows Bob, and then these result in 20 HTTP codes. But that's a DSL that he built for himself. That's what I mean by custom framework, okay? And then test it end to end. Test it end to end, then mocking all the little parts. It's hard, I don't say it's easy, but to some extent you can. However, there will certainly be 10% of use cases that you cannot possibly do that. Because the number of execution paths is just exponential. It's just insane. In those cases, yes, you need to rely on mocks. You need to rely on decoupling logic dependencies. You need to do that. Mocks are inevitable. But there is a catch here. There is a trick. When you indeed introduce mocks in that workflow of yours, make sure that you isolate you don't mock in between every class of your use case, but you mock in between chunks of classes, components. I know that's a old word, but components meaning more than one class. So mocks are inevitable. You can't just write, real life complex application without any mock. Maybe you can, but this gets us to a very old paper, 2004, back in the days in which mocks were just starting to be widely adopted in our profession. Nowadays, I really don't know any project. I don't see any project that doesn't have any mock at all in their tests. So mocks are everywhere today. But back then, they were just, that's a paper, my friends. It's a paper. I'm not sure if the link works. It should work. Yeah, there you go. It's a paper, like a scientific paper. Now, this paper really says mock roles, not objects without a clear contract. What? What do you mean by that? You pour some classes. Okay, good. But then if a class is too heavy, don't just mock it in the same second. First, think about its contract. Is that object really fulfilling a clearly defined role? Can you name that role? Are those methods that you are about to mock really homogeneous? And as a challenge for you, try to extract an interface from the thing that you want to mock. So you are angry with the class because it has too many workflows inside. Okay, I get it. You want to mock that away and test it otherwise afterwards in isolation. But before you do that, try to extract an interface in front of that class. Look at that interface and see whether it makes sense or not. If it doesn't make sense, redesign a bit. Okay, so you should be defining clear contract objects, and that's what you want to mock, not just random classes. Deep one, very deep one. Now, coming back to more basic questions that I am asked in my training. So, folks, I work with hundreds of teams, thousands of developers. They ask me all sorts of basic, both advanced stuff. Right? I worked with super high-tech companies, like everyone doing TDD and pair programming 100% of the time. I worked with people just junior 1 year of experience. One question that I'm commonly asked how many mocks should you tolerate per test? And I'm asked by those developers who saw tests mocking 7 classes or 5 dependencies. And they just were screaming when that test failed. You know what they ended up doing? They deleted that test. Okay, they couldn't figure out, what the heck am I doing? What am I testing? There are too many mocks. So how many mocks? 3. You know, whenever you see a number, a rule 3, always think like, really, why 3? Why not 4? The thing is, I know it's a number, okay, but my personal experience tells that if you get to 4 mocks, things start to get fishy. It's not really clear what are you really doing. And honestly, that's a code smell of high coupling. Why is your class relying on 4 other classes to do its job? Why do you need 1, 2, 3, 4 mocks? Why? And you may have heard that whenever some code is hard to test, it's really usually due to a bad design. You know that. And typically you heard that should refactor production. Yeah, but I will tell you now that you can also refactor tests. What? Yeah. Who said that you ought to test A in isolation? Why not test A plus B together? What are you talking about? I'm talking about instantiating A, instantiating B, and mocking C, D, E. Testing them bundled together. It might be easier. And certainly the number of mocks is lower. But this is interesting, not very usual to do. I would like to see it more. But typically, the production is the problem. And then one easy solution, of course, is to break A in 2. And guess what? 2 dependencies here, 2 dependencies here. Problem solved. Sorry. But there is one more issue, one more refactor you can do. You can tweak the responsibilities. Again, not very obvious. But why not having the D calling E instead? You see? Twisting a bit, moving that part into D. Settling the design such that each class does a sufficient amount of logic of itself. Interesting. Think of it again, otherwise. I will actually advise you go through this again, watch it again. I will post the slides also. So the number of mocks is a good sign of the dependency that you are using. Now let's go to a dark corner. The hidden dependencies. Local date.now. Oops. New date. Oops. Things that apparently are, what the heck? But yeah, but at this moment you are relying on time. So what do you do in case you have some library call that goes to a static method? Well, there's one trick you could do, and please do not use PowerMock, not just yet. That's the last resort in case you can't possibly change the design. But if you care for the design, what I would like you to do is to encapsulate that thing, library call, whatever, into a mockable instance that you pass in as a dependency. And I think you all get the point, right? Time provider. What would the time provider do? Yeah. Take a wild guess, give you the time, and then you can inject this and mock this safely. Nice. So time is a dependency. But this goes further than that. How about the functions, the util functions? We all have those, right? How about those util functions? Should we mock those? Well, utility, there's quite a long discussion here, but in simple terms, if you ever need to mock a function, then that's not a util. Trust me on that. If you ever think of mocking a function, it's not a util. Make it instance method and pass in a well-behaved dependency so that you can do any of these. So it's close into the end. I won't dive more into this. Just trust me. If you ever have the idea of mocking a static function, then that's not that should not be static. Okay. To do a little recap, worst practices in mocking. I didn't even show you, but mocks, returning mocks, it's on the verge of despair. This is you when you do that, and this is you afterwards. Do not do that. Do not have mocks returning mocks. Never. You get the point, right? When then return, surprise, another mock. Right? Ivan, 4 more minutes. Is it okay? Good. Now, mock data objects. This is somewhat related. You should not mock entities, value objects, or DTOs. Do not mock objects which are supposed to carry data. Instead, populate test instances and pass those around. That's what you should be doing with builder or whatever. Too many mocks is a code smell. It means you have too many dependencies. Previous slide. Partial mocks, do not do that. Remember, do not do that. Instead, extract that thing into a separate class and build a home for that piece of logic, right? Separation by layers of abstraction. Do not mock statics. It means that they should not be static, really. Don't verify the methods that you stub, right? When then return, do not do verify afterwards. It's a code smell. You are not following code command query separation, or checking how many times a call had happened or that the method wasn't called. This you might do that when you are testing that you comply to some interaction protocol at the boundary of your system. Not typically useful, and especially this one. Why do you see the method if you are not supposed to call it? Okay, so you get the point. I'm more on a minimalistic style of test. I will test where the risk is. I will not test everything like a maniac. I will test where the risk is. But this leads to the question, what should we mock? Well, of course, legacy code that you do not know, that you do not need to change, that you don't care, that you are afraid of, or out of scope for today. You just mock that as an interim stage before you clean it. Libraries or external systems. Okay, you could mock these out. Okay, as an interim stage, I will actually allow you to use PowerMock, really, just for a while. External systems also, their API doesn't change that often as you, okay, but still, before mocking some external system, do think of WireMock. Do think of raising an HTTP server right from your unit test suite that serves you responses for those HTTP calls very nicely, and you test the whole stuff. Really powerful, especially with record feature. Very cool. Or if you want to go hardcore, there is a Spring Cloud contract. Google that, it's amazing. And then yet a better idea here is to wrap those external systems in an adapter design pattern. Why? Because by mocking your adapter, you will be able to return and receive objects of your own domain. So you see, your adapter will talk to you on your domain model in terms of your entities and value objects. On the other hand, it will, on the other side, it will talk in the terms of structures from them. Mocking it allows you to build tests that remain in your world, talking your object model. So as a guideline, wrap an adapter around an external system and mock the adapter. And in the adapter, you convert the data. Long story here, but I hope you get it. In case there are any kind of questions or you want to explain more stuff, I will remain with you afterwards as long as necessary. Slow or unreliable resources. You can mock these to decouple yourself from a database or from, I don't know, but please first try to run them in memory with test containers or in memory database. Very cool stuff there. And only then, in case you really have large logic classes that you want to test in isolation from one another, do that. Of course, you need to do that. But first, please make sure that contract that lies between them is very clearly defined, has meaning, has purpose. Good. So, as a graph idea, do not if there is something to take from this presentation, don't just mock stuff, because it's a bit harder to test the entire flow. I challenge you to try to test more than before. What are you? Developers. You can do it. You can test more than a single class. Try to test 2 of them for start. Nice. And then for our friend at the beginning, our pure function, a message. And that being said, I'm super eager to hear your questions. So please ask me questions. I already have, I saw that there were some questions, but before that, just a quick stuff. In case you are interested in my blog, Company Training Masterclasses, there is my website there. This is roughly my agenda, my curricula. And in case there are any kind of questions, Ivan, please.
Yeah, thank you. Thank you very much for this energetic, yet again, energetic presentation. So yeah, question kept pouring during your talk, and I will start with the first one. I mean, I will give them in the order they were posted. So the first one was asked by my friend from the Bulgarian Java user group, Kostadin Golev, and he asks, why do you think people actually write when repo.find by ID, and after that a verify, even if it is a query and verify is not needed and you can live without it?
Well, I forgot to tell you something. Before I answered the question, I forgot myself to tell you one thing. Where is it? No, 1 second. Here. I have a news for you. News, and that's not that new anymore. From Mockito version 2.x, anything you stub, so Konstantin, pay attention. Anything you stub will be automatically verified by Mockito by default after the test runs. So you can just tell them to delete all their verifies for the stubbing. It happens automatically. Wait, why does it happen? You have to realize. Because it is also a danger that you might be expecting that something is, not only that, the danger is that you leave bloat in your, imagine today you rely on this method, but tomorrow you don't. Mockito did that such that you can also, such that you clean your tests up and you do not leave useless stubbing. So to make your tests more readable and focused, right? So to start with the beginning, tell them to delete the verifies and upgrade to Mockito 2 and they're fine. Just quick answer. But the real answer, I mean, one of possible reasons is that they are fascinated. Wow. When? Verify, perfect. If you feel that, I know Konstantin and I know your company, and that's probably the case. Your people are probably, I remember you have passionate people there. They are probably super enthusiastic. Do not ruin their pleasure. Do not discourage them. Instead, silently remove all verify and upgrade to 2.x. I mean, I will advise you do that and just let them enjoy it, right? Let them enjoy it. Besides that, there might be a case in which you really need that. Remember, when you both return stuff from methods and you also need to check that these really happen. But I hope that's not the case. Cool. I hope I answered. I would love to have you in the meeting to chat, but in case it's not clear, ask again, okay?
Yeah, good. He has another question, but let's ask the other ones. So Argh asks, I often find myself that when using mocks, I end up with basically replicating prod methods logic in my test methods. Wonder if there is any way around it.
Duplicating, well, to start with the basic, what you put in this place, because I'm pretty sure this is where your problem is, in stubbing. With verifying, what can you duplicate? No. In stubbing, is the issue. Let me tell it out clear. I didn't say it, but you should not be doing computations at all in your tests. You should not be doing computations at all in your tests. It's dangerous. So do not, of course, if you copy paste logic from production, if that logic is flawed, has bugs, then you just copy pasted the bugs in your tests. So that's a clear code smell. Do not do logic, do not do brain, do not do complex stuff in your test, never. And then if you still really have to do it, I wonder if you are not by any chance in this situation, that you have to somehow mock method, that's stubbing really, to stub methods with dynamic callbacks. That's tricky. And you might consider writing a little fake implementation in that case. Although I see a third option here. You could actually put some of that logic in a utility function. I know it's weird, but if the logic is super easy is super basic, instead of copy pasting that little logic, I would honestly think of putting it, but I would expect this is something like 3-4 operations, a plus and an equal and something very, very easy stuff. If it's heavy, that's a risk that you copy paste bugs. Again, I hope I answered. If not, please, folks, answer again. Ask again.
Okay, so the next question is from Rami, and there was some good discussion on his question in our channel. So Rami asks, I would say that's out. No, sorry, that's not one. Yeah, that's the one. Why not have unit tests focus on methods with mock dependencies and have integration tests that do the end-to-end testing and have fewer one integration test per feature?
Let me first start with another discussion, briefly going to some hidden slide. Yes. Unit versus integration. Unfortunately, there are many people out there expressing their opinion and naming integration tests to be those tests that test more than one class together. I actually met people who were confident that that's what is the integration test. Again, naming is just naming. I don't want to argue about terms, but I want to argue about what you do with those words. If you consider integration tests someone else's problem, then you are in deep problems. The integration test and, in my opinion, both end-to-end tests should be the task of a software craftsman, of a truly professional. You should do the whole stuff. Automated test, not manual, but automated. So first, to make things clear, I want you to consider any kind of automated test to be your job. That's just to start off. Then, the distinction between integration and unit test is not that important anymore, really. Because what really matters is that unit tests don't depend on externals. Do not go to database. In the definitions that I like to use, integration tests will talk to an external system that needs to be there somehow, or you might not agree with me. I don't really care if you don't, but I want to tell you the point that I see here. Any taxonomy you choose should have a purpose. In my discussion, my training, I will separate tests in green test and green zone and brown zone. The green tests are never supposed to fail. If they fail, you have a bug, period. If they fail, where is it? If they fail, this should go off in your office. That's a bug, clearly a bug. The problem is that those integration tests, in my opinion, I will name them brown tests. Those can fail for reasons that are not your. It might not be a bug. Sorry. So it might actually be a system down or an incorrect state table or something like that. So any classification you use should have a purpose. My purpose is the following. If a test in this zone fails, and there can be tests that talk to database here, I don't care. If anything here fails, my boss gets an email, my people manager gets an email, I get an email, I get paged. I have a real problem. If a test here fails, it depends. It depends. Maybe run them again, who knows? So you are allowed to have flaky tests here, but none of these should ever fail unless it's your fault. Some teams separate these also in between. It's a matter of taste here. But on the regular basis, or at every commit, ideally, you should run all of these. And maybe during night or maybe twice a day, run these. That's my perspective on these things. So I don't know. I would assume I've answered the question. If not, please clarify it. I know it's difficult this way, but yeah.
Okay, so I think we have time just for the question from Valerio Emanuele. Okay. And he says, Ken Beck, in his book, Test-Driven Development by Example, talks about the maintenance of the test as part of the daily job that is to maintain, evolve the production code. So why did you talk about this maintenance as a bad symptom? Did I get the book or you wrong?
Perfect question. Yeah, brilliant question. I talked about refactoring tests and maintaining tests as a chore, as an unwanted activity, because developers in many companies are mocking every dependency of a class. And this makes it so hard for us to maintain those tests. I know teams that spend twice more time. I personally know teams that spend twice more time to fix tests than to fix production. That's bad TDD. That's bad testing. That's testing too tightly coupled to the implementation. So indeed, it is your job to update and maintain the tests as you evolve the production code, but it should not take you more than it takes you to refactor production. And to get there, you should not be mocking everything around. You should try to think more than just in terms of classes. And that's exactly the point of the training. That's how mocks mock you, by increasing enormously the efforts to maintain those down tests. Why? Because you've tested them too fine-grained, too isolated. I think it makes sense, right? If not, oh, folks, again, this is I'm on Twitter, the best way to reach me. You can reach me everywhere. I'm really interested in your comments, in your concerns, because this is what I teach. So if something is wrong, I have to know it, okay? Okay, that's it.
Yeah, so thanks everyone for joining. Thank you, Victor, for presenting, and wish you everyone a very successful and healthy 2021. Yeah, stay healthy, stay safe, and see you next time.